Hey guys, BBI here. I want to stop and say thanks for tuning in and checking out whatever the video is about that's about ready to come up next. If you could take a minute and hit subscribe, I'd greatly appreciate it. And if you enjoy what you've seen here, make sure to hit the like button. We'd greatly appreciate your support. Anyhow guys, all that aside, let's get on with the show. I normally would have a big long intro of what I'm doing where, and we're just going to cut right to the chase on this because I started looking at it and then I called a customer and he says to me, well, change power cord, which he did. He goes, it kept popping the breakers in the back. I said, oh, okay. So sometimes you got to play the world's smartest detective here. Let's go ahead and tighten in on this little portion of the box down here. So what causes this is one of these chokes goes open and this capacitor will blow up and the grids start taking all the pressure. This is popped. This isn't right. So we're going to just start from the obvious side, which is on the bottom, and we're going to check a couple things down here to just get started. And then we'll wrap around. It's got the Harbach capacitor kit on it and the Harbach aftermarket board on the top for the voltage doubler rectifier circuit on the top side. So first things first, I've already gone over all of this, but let me I'll include you guys in the quick test of what we're going to do here. So you've got this choke here, which we should have conductivity from here to here. So this choke is good, but then when we repeat this process and we come over here, this choke is no good. We should have conductivity through this choke. That choke isn't open. So once again, it's going to cause the tubes to go into imbalance, and we're going to come when that happens always, every single flipping time. Let me undo this here. We'll tighten this up. Every single time when there's an imbalance, this little half quarter wave flipping rectifier unit that's here, this diode and this capacitor that are here, this capacitor ends up getting a bunch of voltage applied to it in a backfeed circuit process. Now I should not be able to take my leads and have a dead short across this cap. Have a dead short across this cap, which I do. And then we're going to take a look across our diode face here. We've got a dead short here also. Okay. So usually when this goes out, that goes out too. But what we're going to do is we're going to go ahead and get rid of all these caps here, because I know the way this guy runs it. We're going to ground these grids. We'll clean up some of this burn mark a little bit better. And then we're going to replace this coax. We'll rebuild that and then we can flip it over and we'll go look at the top side. But this is just on the bottom side what I've figured out. That choke's open. This one's been replaced, but it's going to come out. We're going to ground the grids and then we're going to fix this here. This usually is indicative to having a problem down here. Always. So seen this many times, and what it comes from is this. These wire round chokes are, well, older than, well, dinosaurs were roaming the earth back when they were making these. So they open up over time from age and abuse and a tube going bad, whatever. There's a lot of different things that cause them to open up, but they open up and they go to ground, and then they inevitably blow that circuit up, and then we got to go check the opposite side of the board over on the rectifier side. So give me just a minute. We're going to rebuild this real fast. We'll fix this up real quick, and then we'll be looking at the top side. Okay, Eddie. So we went ahead and we grounded the grids, and I was able to get all the burned up mark and all the score and the burn shit off of this corner of the tube socket. But then I was sitting there looking at this relay. Now you told me you put this relay in because you needed to replace it. I get that. And technically you did it correct, but there's one small problem. Let's get down here Hopefully this will focus up the way I kind of plan it in my head. What we're looking at is this bar right here. That bar is where the RF comes in from the coax connector. It comes down this coax, travels along, comes in through here, okay? Goes across, comes through this tab, transfers over, goes back through this tab, comes out, and then goes to this coax here. Now this is woefully inadequate. This won't work, so I'm going to have to change that out. But while I'm here, I'm going to completely take this relay apart, because if you can't tell, the armor's been scuffing on this. That, we can't have that shorted to ground. That's a no-go. So, unfortunately, this is one of the very few places inside this box that's got to be just absolutely perfect. So I'm going to go ahead and I'm going to take this relay apart, and I'm going to redo all of this. Clean this up, change this around, clean this up, change this around. This is part of your biasing circuit. And then we can come over here and fix this. Just give me just a second. Let me get this all redone over here. Okay, so we went ahead and we rebuilt all the connections on the relay, shortened some stuff up, cleaned some stuff up, made it so that this coax wasn't touching this bar, replaced this bar, and then yes, me being me, I put $12 a foot, $393 in here. So that is definitely more than adequate to carry 100% of anything that you ever going to be able to get out of this amp out of it. The other thing is I went down here and I rebuilt this. I put a brand new cap in here. I've developed this over about 30 or 40 of these sb220s I've worked on. I replaced this cap. There's actually 3 caps in there. Put a new rectification diode in there. The one that came out of here was shorted. That would definitely cause the breaker to pop. So the bottom side's right. This is your glitch choke. We checked it. It's good. Totally good to go. So grounded all the grids. I want to clean this connection up back here a little bit. But other than that, I'm ready to flip this thing over, and let's go take a look at the top side and start going through the rectification bank and checking the capacitors. And because this has got the Harbach board in it, we got to go through and we got to check each one of these protection diodes in here. So, but that is way better than what it was when it came in here. Just a little bit of love. That's all we had to give it. Okay, let's flip this thing up on its top and let's start looking at the top side. Okay, well that all checked out good. Checked every diode. Got good glitch resistor, so we're good to go. Parasitics are good. This here, I've got to clean this up. Just a mental, moral obligation there. But give me just a minute. We're going to hook this thing up. We're going to have some tubes in it here in just a second. We're going to put it through its motions. And we'll see what we got, Eddie, okay? Just when I thought I was out, it pulled me back in. Okay, so we went ahead, Mr. Cruze, and we hooked this thing up on power. Now, you're going to notice a couple things have changed here. First off, let me point out that this thing's wired 110 now. And it's hooked up to my Variac. Everything tested cool. I hooked it up on 220, and as soon as I plugged it in, it popped the breakers. Like, instantly. Instantly popped the breaker. And it popped these the two little resets that are on the back of the sb220. Popped them right out, and I went, oh, snap. So I started looking at it last night. Now, I was running down on 0 fumes last night. Yesterday was an incredibly stressful day. So I went and I looked at this thing, and I had a short. Now, I couldn't figure out if it was in the plate transformer or in the filament transformer. So I come back to it today, and I had it wired in 220 last night. So I went ahead and I converted it over to 110, which was really hard. I mean, instead of having this post jumper together, I put a jumper here and a jumper here and converted it over 110. That way I can hook it up to my 110 volt Variac and just run it up. And so the first thing I did was I isolated out the plate transformer, and the short persisted. So then I isolated out the filament transformer and was able to bring the thing online. Now, what I did notice, kind of stood out to me, was that even with the amplifier in the off position, the fan was still turning on. Now, the way the fan is run is either we're going to float the ground or we're going to common mode the ground for the 220. So What I figured out is the 110 switch had been burned in the on position, one leg of it. So that's a new switch. We're going to slap a new switch in this thing. And we're going to go through the heart-wrenching process of having to take the whole front end of this amplifier off, take the high volt rectifier board off, and we're going to remove the filament transformer and do a filament transformer swap on this sb220. I called Mr. Cruze today and I talked to him about it, and he goes, I don't care. This amplifier is in really good shape. I want to keep it because we're touching on the borderline. There's this line that we all walk as we go through the repair business of when the amplifier is no longer worth repairing. And we're getting really close to that, especially if I would have had to replace both transformers. If I have to replace the filament transformer at $250 and the plate transformer at about $350, you can go buy another sb220 for that same amount of money. Not to mention all the other stuff I've had to fix. So now that I figured out that it's the filament transformer, when the choke, the reason I ground the grids is because the chokes are too flaky. When the choke opened up, caused the grids to become unbalanced. You've probably popped one tube, Mr. Cruze, completely. And that's what all this burn mark that was back here that I just fixed about 2-3 segments ago. And in your mind, that was about 10 minutes ago. In my mind, that was 2 days ago. Cleaned all this burned up off here. What happened is when that unstabilized, I'm sure, absolutely sure at this point, some high voltage jumped across and someplace inside the tube, something shorted, and it whacked the filament transformer and shorted it out. So we're going to find out. I got a nice isolation transformer over here, and once we get this filament transformer out, we're going to hook it up and smoke it up and burn it to the ground. We'll sit it out on the end of the street and see if we can smell the whole cul-de-sac up with it. It's going to be beautiful. But on that note, that's where we're at the moment. Now, as soon as I isolated out the filament transformer, I was able to bring the plate transformer back online. We got our nice indicated 3000 volts displayed, which is good. That means our rectifier circuit's good. It means our voltage doubling circuit, or otherwise our capacitor bank is stable. And with me repairing the on-off switch, that'll put us almost close to done. So, in your mind, it's going to be a blink of an eye. But when we return, the filament transformer will be out. All right, we'll be right back. We say shorted? Oh yeah. Good stuff. Now we'll try the other side of the primary. 25 volts on it and see what happens. Junk. Transformer's dead shorted on the primary. Well, now that we're going to let some ventilation happen, this thing has magically let the goo out, as you guys can all see here. And there's been some moisture in here over the time. This is mold. It's down in there. Don't worry, we'll get all this cleaned out. This is rust. The bottom side of the transformer. Somebody spilled something on this at some point, and they did their best to clean it off, but they weren't able to get the moisture out from underneath the transformer. Anyhow, this little stinky bastard, it's now about 200 degrees, is going to go outside and stink up the outside world and not the inside world. So when we come back, I'll have a new transformer put in here. A new used transformer. But good, which is better than that one, which is junk. So now what's left is a bunch of fit and finish. I got to make the fan run quiet. I'm going to tighten up the capacitor bank and suck that down quite a bit. I got to check on my zero signal. And why I had this off and I replaced that transformer, I went ahead and I tied down your high volt board with the some screws at the bottom. I know those screws are a pain in the ass to get to, but they've got to be there to help keep the board stable. I am kind of questioning a couple things that are on here as far as the bias circuit goes. So I got to check my zero signal and fit and finish and then run it. And then I gotta, while I got the face off, I'm gonna adjust the input tunes for all the bands. And then I gotta flip it over and I gotta neaten everything up because I just literally hooked all the wires up and made sure everything was gonna work. So on low we've got 2,460 volts. On high we've got 3,120. We have a fully functional on-off switch again. And fan is running the way it should. So nothing is looped. The switch is repaired. New filament transformer. Here's our old one. Yay, old smoky. Anywho, keep on going. Okay, Mr. Cruze. So last time we're going to see the bottom side of this thing. Now I went through and I neatened it up. Let's do a quick little recap. First, I cleaned all the burned up mess that was over here in this back corner of the amplifier. Cleaned all that up. I grounded your grids. I grounded this the grid ring. I took all the chokes and all the other solder work that was out of here, cleaned all of this up, made it look like new. Okay. Then we came over here and we completely unsoldered everything from your relay and resoldered it down and cleaned all of that up. Then we went and we upgraded your coax, your output coax. Now, I'm sorry this is way overkill, but this is 393 coax, so it'll handle about 10 times what this amp will ever put out. Then we had to go and rebuild your on-off switch. Then we had to repair your keying circuit, your bias circuit. This is part of your control circuit for your bias. Your bias is actually flopped over here on the relay, but repaired this. Last and not least, I actually put a strain relief on the back of the cabinet because it didn't have one before. This is left wide open, and then there was like a dryer plug that was stuck in here. I went ahead and put a brand new power wire lead hookup on it, cleaned up all your solder joints here on your breaker panels, and then we replaced your filament transformer. And then I went through and I hand tied all of this. So now it's all nice and neat and organized and clean and good to go. So the last thing I got to do before I flip it over is I got to convert this thing to 220, which is I got to remove this jumper and put this jumper back in its place between these two spots. So we're going to bang that out real quick, and then off to finally working on the top side and making this thing work for you. Okay. $1,000-watt slug and peak, average. 1,000-watt slug, also 5-watt slug in reverse back from the Bird 10,000-watt dummy load. We're going to hit it with the 2950 here. We're going to put about 10 watts of drive in it. It's working. That's on high, by the way. 10 watts of drive, I'll take 600 out. Got your input tuned down nice and flat for you, by the way, too, Mr. Cruze. Okay, the only thing left to do is now put the face on it and get all the meters working. Fan's fixed, filament transformer's fixed, the whole bottom side of the amp's been rebuilt. Okay, let's drop the face on. I think we're ready to go. This has been a long path to get to this point. Mr. Cruze, your lids, your face and the sides are back on. Guess what? Here's your high voltage. Here's your zero signal. I had to disconnect the Zener that was down in here. The new aftermarket board that's in there, Mr. Cruze, takes care of the bias. You don't need that. And actually that could have been part of your problem. I don't know how long you were running it with that board in there and that Zener in there, but that can cause you lots of issues. So our zero signal is now correct. That's zero signal. See that? Now look at our grid meter. It's sitting in 0. Now the way the grid meter was wired when it came in here, Mr. Cruze, it would have never worked. It would have never worked. About 150 mils on the grid. Okay? Relative power, or your voltmeter's working. It's working perfect. Plate ampere meter is working. 1000 watt slug in 5X, 1000 watt in average, 5 watt slug in reverse back from the bird, 10,000 watt dummy load, 2 pill drive in the 2950. We're just floating. 2400 peak watts. Look at where I've got all your knobs indexed. And then the other thing I wanted to tell you is I went ahead and I replaced your band knob. Let's see, where's your giant bag of parts? Here it is, down here. I went ahead and replaced your band knob. Down here there's this, your journal housing. The threads on a couple of the set screws are so messed up that I couldn't get that to get locked up. And the edge of the bezel face was all bent up. So I just went ahead and I grabbed another one off the shelf. Make it look all right and proper and pretty and premed and clean and good for you. So let me show you what I'm putting into this for drive. Just about 200 watts. 200 watts in. And 600 bird out. 2200 peak. Let's go ahead and shut this one down. We're going to go over here to the derail Wolfman radio. Now we're going to get Silly Bird out of it. And I mean Silly Bird. Okay. Hello. Same amount of drive. Hello. That's right. Turn our voltage up a little bit. Hello. Same amount of drive. Hello. Hello. Let's see if I can peak that out a little bit better for us. Hello. Hello. That's about the best we're going to get out of it. 900 bird, and a full 2500 peak watts. And that's driving the Jesus out of it with the derail Cobra 29. So Mr. Cruze, you're all done. This has been a long project. And I've had some personal stuff going on. I've had a major injury in my family, not my immediate family, but close. I've had a loss of a couple friends, and I'm just glad we're done. Mr. Cruze, I appreciate you sending this thing up, being patient enough to let me go through it for you. Guys, I'm always here, but I've got a life too, and I've got a ton going on all the time. And remember, I don't do this for a living, I do this for fun. And, you guys got to be patient. If you send me something, you're going to get it taken care of by one of the best in the industry. And you're going to get one of these videos to watch. Nothing leaves here without a video being made of it. Nothing. No one else in the business takes the time to do this for free on every single product. So keep that in mind as well. Mr. Cruze, you are now 10-8 and perfectly straight. And this thing is on its way to you. Gentlemen, my name is BBI. If you've got an sb220 that is as a hurting unit as this thing, send it to me. I'll breathe life back into it, and you guys can have fun talking on it once again. Mr. Cruze, I'm going to give you a call this evening. We're done. Come follow me on Facebook, Twitter, Snapchat, Instagram, and if you are watching this for the very first time, and you like what you've seen, just click subscribe. Make sure to hit the notification button. That way you can follow along with all the crazy antics that happen on over here at the BBI House of Pain. Gentlemen, I've got to go. I got to put a fan on this, let my tubes cool off. Pull my tubes out, put the lid back on this, put the armor on it, and get it sent out the door. And I'll send you back your stock power plug too, Mr. Cruze. You're going to have to go get a new power in for it, new plug in for it, but we've got real rated wire for it with a strain relief. And, oh yeah, forgot to show you. I totally cleaned up your parasitics and made them all look like new up here. Got that all cleaned up too. I don't think there was a whole lot left in this box that I haven't touched or put my hands on or redone or resoldered, so I got nothing left. Guys, I gotta go. I'll see ya. Bye.